All right. Thank you for coming. My name is Joe Grand, and I am a hardware hacker. I don't have a clicker, so I'm going to have to keep running back this way, so it'll keep you awake as I walk back and forth. Thank you for having me. Thank you to the Hack in the Box crew. I first gave a talk at Hack in the Box in 2008 in Malaysia, so this is my first time back to Hack in the Box 14 years ago, which feels like a different lifetime ago. And the conference has grown and the industry has grown, and it's just very, very cool to be back here. This particular talk, normally I give technical talks about security or about hacking. This I thought would be kind of fun to talk about failures. And, a lot of times when we go to presentations, we read papers, we hear about the successes of somebody, finding an exploit, weaponizing an exploit, how they, succeeded in breaking something. But to me personally, the failures and things that didn't work and the process of getting to that point of stumbling and failing and falling and trying again and getting up and then finally doing it, those are the steps to me that are more interesting. And as a hacker, being constantly curious about how things work and learning new things, I think that's really cool. So I thought that I would do a presentation about that. So it's, kind of admitting my failures and the examples I'm going to give you are not really like sensational, like, oh, wow, that's, a huge failure, but it's something that stuck with me. And as we go through these sort of chronologically, not really at every stage of my career, but like different projects along the way that I remember and I really remember. So every time I work on something new, I think about what's happened in the past with these examples. So of course there's many more, right? Because as humans, we're failing. And I think hopefully like the takeaway of this is that it's okay to fail and you don't have to be embarrassed about it or have imposter syndrome, feeling you're not worthy enough, which happens to all of us. And in this community, in this world, being a hacker or a human, like a lot of times you're sort of told or it's almost implied that you shouldn't be failing and you shouldn't be making mistakes. So that's what this is all about. This is kind of the theme of my presentation is the facepalm moments that have really stuck with me. I just found this quote recently. I hadn't heard about this person before, but he was an early educator, in the US, and he had said, "We do not learn from experience, we learn from reflecting on experience." And this took me many, many, many years to realize, like, oh, the things that I learned along the way as I was growing up, or problems that I faced or something that happened, until you step back and look at it and say, oh, it wasn't that bad. That was actually something I could take and flip over and use to my advantage. So it took a long time especially one of the first examples I'll give you, hurt a lot emotionally and physically for a long time. And finally, 20 years later, I go, oh, that's okay that happened because that brought me to where I am now, right? So everything has a silver lining. Everything has a reason that you can find that's good. So the important thing is to kind of step back and look at it from a reflection perspective. So I grew up as a hacker. In 1982, I got involved in computers. And this is a picture of me. I think I was 10 years old at the time, so this was 1985. I had my Atari 400 computer with a modem that you can't see, but I had discovered bulletin board systems. I just loved connecting to other computers, sharing information. And this was my world, this little tiny room in my parents' house with a phone line to connect to the rest of the world. And this was it. As soon as I discovered computers, I knew that this was something special. And I think it was also a way for me to have some power and some control in an environment where being like a, kind of computer nerd was not a cool thing at the time. But look who's laughing now. So this is kind of how I spent my days, coming home from school, using my computer and discovering at the time was a very small hacker community. It was worldwide, but it was pockets all over the place. And to even connect with people that were outside of your local area was a huge task to figure out either how to make free phone calls or connect to some sort of network that was connected. This was sort of pre-public internet. So it really was fascinating. And anytime you found somebody online, you knew it was like one of your people, right? And that's so special. And that's kind of what we have now with conferences in person, where we come together and like, we know, even if we do completely separate things, we're still hackers, right? And we know each other's mindset, and we kind of can connect with each other on that level. So this was how I started out. And I got involved in like some hacker groups, and we would write text files on things like how to steal credit card numbers and how to use credit card numbers. I guess nowadays that would be like identity theft, and, you know, major organized crime groups are doing this now and hacking credit bureaus and stuff like that. But for us, it was literally teenagers causing mischief. And for me, it was a way to cause mischief online instead of doing it kind of on the streets, which ended up coming back to me anyway. So for me, this was all normal of sharing information, even though it maybe wasn't legal. It was still sharing information and having power that other people didn't have. But I always knew personally and ethically I would never damage any other system, right? So it's not like the malicious sort of hackers you see now. It was all curiosity based, and it just seemed normal of like, oh, I'm going to hack that credit bureau. They're a giant company anyway, and I'm going to use that person's credit card. They'll get paid back by the bank. Like, it totally seemed normal, which now as that I'm older, I'm like, I hope my kids never do that. But it's something that, you know, that's how the community was. But that eventually brought me to my first life turning point, which was getting arrested when I was 15 years old. And this was not for computer crime, because the laws were so vague back then anyway. This was for actually physically breaking into a telephone company building so I could get documentation and information about how the phone system worked. It was that curiosity and that quest for knowledge that you just couldn't get unless you did something like that. Which, again, it sounds kind of weird, but like this was totally normal to me. Of like, oh, I'm going to break into the phone company, which is not normal, right? But at the time, it seemed totally fine. So this was the first turning point, and my parents knew that they would never be able to get me away from technology because I was so fascinated with it at that time. And it just so happened that where I grew up in Boston, Massachusetts, in the United States, was sort of a hotbed of kind of hacker mentality. And I had known some people before then from bulletin board systems, and we had little gatherings of hackers, but I ended up joining up with a hacker group called the L0pht, which was just starting to form in the early 90s. This was 1991, 1992. And this was a place where there were 7 hackers who would store all of their junk and all of their equipment, and we had a hacker space. And for me, as the youngest one by many, many years, it was a way to keep me out of trouble. And this is where I learned to not do things like break the law, but hack on things in my own controlled environment. We could set up our own computers. We could set up our own networks. We can hack on things in our little electronics lab, which you can't see here, all for learning and for sharing without breaking the law. So this was a real change for me of like, oh, I can still do what I love to do, and I can do it in a way that isn't going to harm other people. And this was really cool and very, very, for me, what's the word? Formative time of my life. I was 15 years old when I joined the L0pht, and that lasted through about age 22. So remember when you were a teenager, what happened in your teenage years. Like, this was something where I was surrounded by really smart hackers and mentored, whether they knew it or not. They were kind of my surrogate parents, you know, like mentoring me through life, not just from hacking, but just how to kind of handle myself and how to respect other people and go to conferences and share information and learn from other people. So it was really special. I can never overestimate how important this time was. Besides the personal connections that we had, we were also starting to share the good side of what hackers can do. Saying, okay, you know, hackers can be good. We can share information and help people and find vulnerabilities and force companies to fix those problems. So we were doing very early, like, full disclosure types of things of forcing companies to fix things, where Microsoft would be like, you know, we'd show them an exploit and they're like, no one's ever going to do that. And then, you know, something would happen. They go, oh, okay, maybe we should fix the problem. So we really had no responsibilities, right? We were just some kids technically in a clubhouse. The industry hadn't really formed around it, but that was really fun to sort of spread that message. Probably what most people know us for is from testifying in front of the Senate in 1998 about computer security. And it was the first time that hackers had met with the U.S. government in a in a friendly way instead of in a non-friendly way. But that's only what people know. They didn't really see the backside and the fun and the trials and troubles that we had kind of behind the scenes. What we ended up doing and why this is a failure in my eyes and something I could learn from is we had this great hacker group. We were doing everything we loved to do. We were hacking on stuff. It wasn't full time. We were just doing it for fun. At that point, we all had jobs. I was a professional computer engineer designing products. We decided, what if we could start a company to be hackers full time? Which nowadays sounds totally normal, right? Because you can do research. You can go to hacker conferences. You can do all this stuff. This was like, people thought we were crazy. No one's going to pay you to do research and write vulnerabilities, and, you couldn't sell vulnerabilities and make money or do anything. It was totally unheard of. But we thought it would be fun to do. Let's try this. Let's sell our hacker group to some venture capitalists and start a company. Sounded great. We got a little bit of buyout money, and it was the first L0pht sells out, hackers sell out. And we kind of went along with the ride, and it was a consulting company. So everything came down to how many hours could you work to make money for the company. The thrill of the hacking and the purity of the curiosity went away. It was all about what can we do for the customer to make them feel better, which is a great thing to have. But from my perspective of growing up as a teenager in a group that was almost an anarchist collective, to go to this hierarchy structure was very hard, and working with people who didn't necessarily understand what hackers were all about. And we tried to shape that, but it was still difficult. Here's a picture of us after we'd started the company. This was in 2000 at the RSA conference, our launch party. So now we're all wearing our more corporate shirts, kind of trying to blend into the community and kickstart this industry, really. Most people were fine with it, but for me, I just took it really personally when we lost that kind of edge of being hackers and more of just being billable assets. So I won't go into every detail about it, but Space Rogue, which is this guy over here, who looked grumpy for many, many, many years, and I finally saw a smile on his face recently. He wrote a book recently about the whole process, his view of it. But what ended up happening with that stake, which is what personally hurt for so long and what I dealt with for so long, is we all kind of, as friends, we all kind of split apart because money got involved and things that we didn't truly believe in took over, right? We had to start wearing suits to go to meetings and all of these things that we would never do except this kind of carrot that we were chasing of money, really, not even fame, but it just changed the whole dynamic. And a lot of us didn't talk for a long time. And one of the main pieces is when we started at Stake, Space Rogue, one of the hackers in the L0pht, was put into the marketing group. And his job was to write news articles. So he was in a separate spot outside of the hacker lab. And we were like, okay, fine, he can go to marketing. And then they fired him and said, we don't need marketing. So they basically fired one of our guys, one of our group, and none of us did anything. And that stuck with me for a long, long, long time. And I've talked to Space Rogue about it. And that's something where the lesson of this and the failure of this is not following your heart and not standing up for your friends and not valuing the relationships that we had. And of course, I didn't realize that until a couple years ago. So that's, something that was such a huge life-changing event, reminded me of you can still do what you love and you can still support your friends at the same time. So I have a couple project-related failures that, again, have really stuck with me. This is a project that I'd worked on at the same time as we were just about starting at Stake. I was working at a product development company designing electronics, and this was a medical device, a portable infusion pump. So if you've ever been to a hospital and they give you the IV and they're dripping medication into you, this was the first machine that you could carry around that was battery powered, that wasn't this giant thing attached to the wall. So it ended up being a kind of a big deal that I didn't know that at the time. I was just helping design the electronics. And there was a whole bunch of people on the team from our company and then the client's company. And we kind of went through the typical development process of prototyping with larger electronics, miniaturizing it, and then getting it to fit into the final form. And here you can see it in a little screenshot of a television show called ER, which is a very popular kind of medical drama back in the day. So it was a really fun project. And I was sort of tasked as like the junior level engineer to do the overall system design and integrate the other more senior designers' sections of the design into one. So I was kind of leading the schematic development and the helping the circuit board layout person get things right. So kind of just leading things, but having some oversight as well. The first revision of the schematic, and a schematic is an electronic roadmap of how an electronic system is designed, which is always a step in the process when you're building something. It's just a way you can step back and see how everything's connected and say, okay, now I see how, the I/O pins go here and something goes here, and it's a typical electronics, hardware, related step. So I went into the design review with the customer and all the engineers and said, here's the first draft of the design, and this was like 30 pages of schematics. It was a very complicated design. And I remember the first thing one of the guys said, and if you're not into electronics, it probably won't make sense, but it was a very stabbed in the heart. He's like, where are your bypass capacitors? I'm like, what are those? I had no idea, because most of what I learned was self-taught. I did go to university for electronics, but they didn't talk about bypass capacitors. It turns out that bypass capacitors are required on every single power line going to a digital device to help clean the power signal before it goes to the chip. It just helps reduce noise and helps increase stability of the chips. But I had no idea. And this was something like engineering 101. Like people should know, but it's not always implied. So for me, it was kind of like, ooh, that's pretty embarrassing. Here I am, in charge of drawing the schematic, and then I don't even put in components that are required. So it was kind of embarrassing to me, but nobody made fun of me for it. They just said, okay, here's what you should do. Add the bypass capacitors here. We can use 0.1 microfarad here, and, on different power lines, maybe use different ones. And they stepped me through the process. So for me, it was this eye-opening moment of, you'll never know everything, right? Because even at the time, 20-something years old, I'm like, I'm designing this schematic, had this kind of ego about it. But at the same time, it was this willingness to learn from other people. And I was just lucky enough that the people in that company were guiding me. So the lesson, I guess, here is kind of if you can find mentors or people that are willing to teach, that's great. Or at least surround yourself with people that aren't going to make fun of you if you make a mistake like this. Because nothing feels worse than if someone was like, oh, you're so dumb. I can't believe you didn't do that. Right? So this was something from 23 years ago that every time I design a circuit board, I think of this moment. And I always think about, where are my bypass capacitors? There they are. I didn't realize I had them circled. This was the second revision of the schematic. So it's okay, got my proper decoupling in place. So another electronics-related one, this was from the DEF CON 15 electronic badge. So this was very early in electronic badge world. This was the second badge that I had designed, and as far as we know, sort of the second electronic badge in the hacker community. And the concept and the goal of these badges back in the day was to do something with electronics, use the circuit boards as kind of an artistic element, and then do something fun that is practical for the conference, but then also hackable for people who want to screw around with it. And the first year, DEF CON 14 was basically the DEF CON logo, the skull and the happy face with blinking eyes, and you could change what the blinking eyes do. So people could hack on that, and there's a little microcontroller on there. So this one we decided to do, a scrolling LED kind of matrix that had different functionality in it. You could program your name, you could do all sorts of other stuff with it. And one of the new features that I had wanted to use, and part of the fun of doing these badge designs that weren't for a actual product, but for a hacker conference, is you could try different techniques that you wouldn't normally try otherwise. It's sort of like if you're hacking on something and writing a piece of code, and it's oh, I just want to try this library and see if that works better. So this way I could try different techniques that I haven't used in my professional career, but have someone else kind of fund the development effort. So I wanted to use capacitive touch sensing buttons. So the three icons of the badge, you would touch them, and that's what you would use as the user interface to change your different features. So that's kind of the overall concept. As I went through the development process, so again, here are some typical kind of engineering development photos of the upper left. I'm starting the development and trying out some different things. And then I ended up getting the first proof of concept prototype back. So something that would look and feel the same as the actual design. And this was probably like, I don't know, maybe like a month or two before the conference. So there was a hard deadline, right? Like thousands of hackers were going to show up at DEF CON in Las Vegas, and this had to be done. So I got the design back and realized that the capacitive touch buttons weren't working. And I'm like, well, that's weird because it worked on my prototype. So what changed? And it turns out by reading the manual again, the documentation for the capacitive touch buttons, I had completely skipped the fact of what voltage was required for the actual capacitive buttons. So when I was running my prototype, I was powering it from a power supply. When I had the proof of concept prototype, I had a single battery. So the voltage levels weren't right, and I totally missed it. And my heart sank, and I was like, I'm totally screwed. Because how am I going to redesign this whole thing in time for the conference? So what I ended up having to do as a quick fix, instead of having a single battery, which was what I wanted because it was nice and kind of symmetrical and balanced and simple, I had to add another battery holder on there, which to me is like, this compromise, but at the same time, it solved the problem, got it working, made a good story. And that was something that I realized, okay, we all talk about RTFM, right? Like read the manual. This is really that situation of even if you think you read the manual, you might miss something. And that's okay, right? It just takes a little bit of effort to kind of come around and fix that. There's some other difference between these two that really struck me. This is kind of hard to see anyway. It's English in its reverse, but it should say Uber, U-B-E-R, and it's kind of a stencil cutout, but this bottom part's missing. And it's like, wait, that shouldn't look like that. So I had to change the design to get it to actually be the right thing. And that was just an oversight of not testing and not printing out, or not mocking up my design before sending it out to fabrication. So all in all, like minor problems, but things that could have been bigger problems and things that could have been solved with just being a little more careful along the way. Yeah, and then I found in the documentation, it's, have a separate voltage regulator, blah, 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 and that's where I had to add the extra battery. But everyone had fun with it, and it turned out okay at the end. This was a shot of like closing ceremonies with everybody holding their badge and waving it. And you'd display with a persistence of vision, you'd see like text come out, DEF CON, when you moved your badge back and forth. So in around 2007, 2008, I decided to kind of get out of hacking as far as like giving presentations and hacking on stuff, and started working on a television show called Prototype This. And the goal here was similar to kind of what we did at the Loft, where we were like showing the good side of hackers. This show was all about showing the engineering process and trying to get kids involved in engineering. And it was for engineers building prototypes of wild and crazy things. So we had Terry, who is a special effects like master from Hollywood, me, much younger, Zaz, who's a computer scientist and robotics guy who turns out also goes to hacker conferences, but we had never met at that time. And then Mike North, who's a material scientist. So we came up with all sorts of different concepts and filmed the process. And it aired on Discovery Channel. It's available on the internet if you know where to look. And there are a couple conversions into Thai as well. And it was really fun to show this process. And we had a lot of problems from the production side, from the engineering side. But the main one that stuck with me is this one. This was a project that we called the 6x6. And it basically was mimicking the alternating tripod gate of like a bug that has 6 legs, and there's 3 legs that are on the ground at all time. So if you ever look at a bug like a beetle or something like that, and you can watch it move, you'll see it's 3 legs at a time. So we were trying to take a small model that some students had created at a university, which looks like this. It's kind of walking over any sort of surface, which is like a cool little robot. We were like, we want to make a human rideable version of this. And this was one of the episodes. I should mention too, when we started proposing what things to build for the show, the production company who was paying for all of this was like, we need to make sure that you succeed every single time. And we're like, that's impossible. How are we going to know if we can succeed? Like, engineering doesn't always lead to success. But they didn't know that. Their mindset was success leads to advertising dollars, which leads to money. And more people watching the show. So this was the first episode where we did not succeed. I'll spoil it with that. But the result was not what we expected. So as we started going through the process, we built our design. We had carbon fiber legs and some electronics to deal with the stability. It was a PID loop and some pretty detailed kind of control systems for this. And here's like our first attempt of trying to get it to stand up with the 6 motor controllers to see if it could like get stable on its own. And it basically just falls over. And we're like, okay, well, we can run the motor controllers, but that's not standing on its own. There's no way a human's going to go into that and walk around. So we tried and tried again. And then we're doing some testing. See if I don't know if we have the volume on here. I don't think we do. But here now we're testing the motor controllers to see like, why is it not able to be stable? So this is Hal. He's the inventor of the original robot, pushing on the leg. And I don't know if you can see it, but there's smoke coming out of the motor controller. So the whole system was completely under-designed. We used motor controllers that were too small. The chassis for this thing was made out of steel because the safety people said, you need to have a steel chassis instead of a lighter weight aluminum chassis, which basically like tripled the weight. So just that one decision trickled down to everything else and affected the rest of the design. And remember that we're filming this for like mass distribution of television. And everybody expected us to succeed. So we kept working some more. We did some redesign and we went way over budget, way over time, like multiple weeks over time, where we were supposed to get this done in 2 weeks, by the way. And now we're in like week 6. This is a handmade video, so the lighting's not good. But we can see like we're in like our warehouse. It's dark, getting the legs going. And now things seem to be working a little better. We're standing. And we're like, whoa, it's standing. Like it's actually stable. This thing is going. So it's like these little decisions and changes over time. Like now we're actually able to stand in it. What we haven't tried to do is walk or really put a human in it, but we were getting there. And then the production company was like, all right, you guys have to be done. Like now we don't even care if you succeed. Like we don't want to spend any more money on it, but they still wanted to try to shoot this finale about trying to get it working. And this is kind of where we left it. So it will stand up, right? But it's just not walking, right? It's like the control systems that we have in place just aren't able to handle the weight and the size compared to the control system that was used in the smaller vehicle. And it's just so sad because we were so close. And the lesson here, once the production company realized that we failed, they're telling a story now, not about success, but they're telling a story about actual engineering and real life problem solving. And once they saw the footage, they're like, this is amazing. We love when you fail. And we're like, yes, finally they get it. So they understood that engineering and hacking is not always about success. Failing is okay. We knew exactly what we needed to do to fix the problem. We just we weren't given the time to do it. And the other lesson about this for our perspective is, if you set your mind on the problem for long enough, you'll be able to get there. Just depends on if you're given that opportunity to do it. But it was really kind of special for everybody involved to realize that it was okay to fail. This example is a quick one and a very embarrassing one, and I can't give specific details, but let's just say that I was helping somebody hack on a very popular electric vehicle. And this is the infotainment unit for the vehicle. I don't know if you notice anything weird about this right off the bat, which probably should have been a red flag for me. So it's in a driveway, and this is a giant pillow. So here we're sitting this, I don't know, couple $1,000 US piece of electronics that helps control the car on a pillow in somebody's driveway. So that should have been like, wait, we should do this in like a proper environment and do things properly. But I was just so excited to get the opportunity to look inside of circuitry for one of these vehicles. So our goal here was to try to find some hardware vulnerabilities, or at least some way that we could get hardware access that would give us software control to, I don't know if it was Linux may have been Linux, some operating system on here. And a lot of times with hardware hacking, that's the goal, is finding something in hardware that we can access that gives us software control. So we're poking around. I had my oscilloscope, which lets me see different signals. I had that sitting in the passenger seat, and I'm kind of probing around on the circuit board. And all of a sudden, the pillow slips. And this whole front face, which had the touch screen that controlled the entire UI of the car, fell down. And I go, oh no, that was bad. And then we powered up the unit again and it wasn't working. And we're like, what is going on? Why? It just fell over. It wasn't like, we didn't hear anything break. But upon further investigation, there's a tiny little tear in one of the flexible cables that connected the touch screen to the rest of the system. So if this was like an actual consulting project for a customer and you messed up like that, you'd say, hey, sorry, can we get a replacement part? Can we get a replacement vehicle? It wouldn't have been a big deal, right? It's just a roadblock. But it turns out that this vehicle was not a sanctioned hack, and it was actually a rental car that this guy had bought to look at. So the lesson here is ask questions before you get involved in a project, understand what the actual situation is, and then also trust your gut. Again, trust your gut. It comes back to that a lot. Of seeing those pillows, I should have stepped back right away. But I was just so excited about that. The hacker curiosity kind of got the best of me. And this was a huge problem because now we had to bring it back to the rental company. And we're like, the touchscreen didn't work. So the heat was on full blast and it clearly did not work. And the company took it back anyway. And I don't know what ended up happening with that person and that project they were trying to do. But this was probably not one of my best decisions. And don't use pillows to hold up sensitive electronics. I think that's the final answer. Here's another electronics one that also, again, it's not a huge groundbreaking discovery, but it's something that I still remember. And this is another project that I had designed. It's an RFID reader designed for hobbyists, so you can use, programmable RFID tags. You can read and write data and use it for access control and things like that, like NFC types of applications. This is the fourth version of a bunch of RFID readers that I had built. And they were sold by a company called Parallax who sells hobbyist electronics. Because I don't like selling my own stuff. It's better to just design it, let someone else deal with it. So it should have been I was just adding some USB capability and changing from what we called the serial version, which was a simple serial interface, to a USB interface. But for some reason, when I did that, I was getting all sorts of misbehavior and kind of problems with the device, which doesn't make sense because I wasn't doing anything major to change the design. This project ended up taking me, what do I say in my notes? I think it's 5 years to troubleshoot this problem. And it turns out that when I changed the layout of the board, that changed the requirements for tuning the antenna, the RFID antenna, to the point where even if I was able to tune the antenna, it was being more sensitive than normal and picking up noise all the time. So what I basically am showing here is a signal that I was receiving from the device and then a known good signal from the previous version, the serial version of the device. And it's impossible to see they are different, yes, but because they're different ones and zeros, but there's nothing obvious of that's, of course, that's the problem. So it turns out that the noise that was being generated was being treated as the data. So anytime you tried to read a card, sometimes it would work, sometimes it would say it's reading a card when it wasn't, and it was just a pure noise-related issue. But it took 5 years of troubleshooting, taking things apart, redesigning, adding circuitry like this to try different things. And I started really questioning, this is where imposter syndrome comes into play. I started questioning myself of am I even worthy of calling myself an engineer? And this was what was the year? This maybe was, 10 or 15 years into my engineering career by that point. And I'm still questioning myself. Am I built for this? Should I be doing engineering anymore? Why is this not working? What's wrong with me? And just kept trying over and over again. And then finally one day I'm what if I change this capacitor? Single value. What if I just change that to make the antenna less sensitive? And that's what it was. A single 10-cent part fixed the design after all these years of stressing about it. So I guess the lesson here is there's no need to kind of blame yourself, right? And question yourself. Like, yes, it was a mistake. But if you flip it of like, it wasn't my fault, but it was a really good engineering challenge or hacker challenge, however you want to think about it. Like, let's just take it as what it is. It's a problem. Let's solve it. Let's go through it. And yeah, it took a lot of time out of my life, but the end result is that we got it working, and that was pretty cool. Oh yeah, here's some of the notes that I was doing of I got to the point of being so desperate about what was going on is I didn't even trust the code that I had written for the microcontroller that was taking in the RFID demodulated data. Like I was certain that there was some bug in the code or something. Like I was just completely desperate. So I started manually decoding the bits that I was capturing from my RFID side, the RF front end of the system. And like, this is stuff that the software is supposed to do for me, and I'm looking for errors and all this stuff. But yeah, it was a big deal. And then the change ended up being just one component value change. So sometimes issues that appear really, really complicated are simple problems. And maybe what I should have done is, instead of diving right into trying to locate the problem, like maybe just thought about it more from an overall view before going too deep. This example is from hacking a hardware wallet called the Trezor One, which is a cryptocurrency hardware wallet that stores your private keys. And this was a project that we ended up filming, made a video about it. It's on YouTube. But basically a guy emailed me at a time where I wasn't traveling and wasn't really doing too much. And he's like, hey, I have $2 million on a device. Can you help me recover I forgot the PIN. Can you help me recover the funds? And I was like, oh, that sounds like an interesting idea. Like, I'd never looked at those devices before. I never paid attention to cryptocurrency, but got thrust into it unknowingly. And this particular device had already been known to have some vulnerabilities given some other research that was out there in the community. So I said, sure, I'll be able to replicate some work that my friends have done and help this guy get his money back. That turned into 3 months of hardcore reverse engineering and hacking to basically take what was public and get it to a point that I was comfortable with, that I understood what it was doing, and to actually get it working at all. So it's a whole process, a really fun story, and for me personally, a great excuse to work with a technique called fault injection, which is a really kind of up-and-coming, still an advanced technique, but a really up-and-coming way of tricking chips into bypassing instructions or changing the data that it's reading, and basically using it to skip over authentication checks and code protection and security and things. So it was a very, very cool technique. Of course, it was like learning it as fast as I could to help recover money, where it would have probably been a lot less stressful if I was just doing it for fun, without that piece. But anyway, this is the whole thing. This was my kind of typical setup that I had at the time for that. And as we were doing the project, my wife said, who's sitting back there right in the middle, she said, you should be filming this project. Like, people should see the hacking process, because a lot of the videos I've made at the time were like engineering related and prototype this and not really hacking. So she's like, people need to know that you're still a hacker. So I called a friend of mine who's a filmmaker and said, hey, do you want to come film this process? Like, the guy is going to fly over from the other side of the country. He's going to bring his Trezor. We're going to hack it. Do you want to film the whole thing? So he ended up coming and filming this whole process, which was very, very cool. It was almost like a prototype this type of process, but with hacking, explaining the process and going through it. And by the time we got to this point was the 3 months of trial and error and trying different devices and getting everything. So I was fairly confident that it was going to work, but not really. And the failure in this case, oh yeah, so here's like the different pieces that I'm using that, again, I go through the details in the video, but the failure of why I mention it in this presentation is, once I got everything set up with the customer, Dan, with his device, I wasn't seeing on the oscilloscope what I expected to see. So I'd already done this like 3 or 4 times with other devices, so I knew exactly what I should be seeing every step along the way. But when I hooked his up and we're filming it, and we have the lights and the cameras and all this pressure, it wasn't the same. And that made me really worried, right? Because when you're hacking on something, you want to have consistency between like your test device and the real world thing. So that got me worried. And I was like, maybe it's some interference. Like, what's different between when I did this on my own in the lab and when there's a bunch of people in here with the lights and the camera and the wireless microphones and everything? So I started troubleshooting this issue by thinking about the potential causes of this difference I was seeing. And he had like just flown in 6 hours to get here, and like already we had a problem. So here I'm like, maybe we should turn off the lights. Maybe the lights are causing some interference that I don't remember seeing before. That didn't work. Then it's like, all right, let's turn off our microphones. This is part of the video, by the way, so you can see it in real time. But it was like, let's turn off the microphones because those are transmitting, wirelessly. Maybe that's causing the oscilloscope probe to show something different, or if it's affecting the chip operation in some way. Turn off the microphones, still nothing. And I'm like, oh man, what if I disconnect Wi-Fi from the oscilloscope? You can't see it on the slides here very well, but I have a little Ethernet to Wi-Fi adapter because my oscilloscope has network connectivity, so I can take screenshots and control the scope if I want to. I was like, maybe the Wi-Fi adapter is causing problems. So I took the Wi-Fi off. That didn't help. And then eventually, I was sitting there and I'm like, what could it be? And I'm reviewing everything. And I said, oh no. What I forgot was something called the ground clip, which ground is basically like a 0-volt reference, a shared reference for any time you connect electronic devices together, whether they're chips or whether it's an oscilloscope to a piece of equipment or whatever it is, you need to have ground. So all the devices kind of had their shared reference of what voltages are and what they look like. With my oscilloscope, I was so nervous about everything happening around me, I forgot to clip the ground clip, which is another one of these like engineering 101 moments. Always connect your ground. But it happens all the time to everybody. In some of the classes that I teach, it's always we forget to connect ground. So things might work a little bit, but they don't fully work because there's not that reference. And this was the same situation where I could see something on the screen, but it wasn't right. As soon as I realized that and connected ground, everything looked perfect on the screen. And I was like, yes, it works. Or I think it works. And this is just showing like what a voltage glitch looks like for fault injection, of basically like turning off the power really quickly to the microcontroller at the exact point in time to skip over the security check that would then give me access to the chip. So the fact that I could see this, super happy. We did end up succeeding, and we caught it on film of this like many hour process, and it ended up being great. But that lesson again is like simple things can cause big problems. Just that ground connection was like, very stressful. So this was like a year and a half ago, 2 years ago. And that's something where I'm constantly thinking about that. If there's a problem, it's like, check your ground, check your other connections, right? Little things can lead to bigger things. And then the final failure that has stuck with me. This is an example of no matter how long you've been a hacker, no matter how long you've been alive, you will always fail and you will always learn something new. So this is a recent project that I've been working on, basically taking some memory off of a device so I can read the contents out of it, which should be a pretty straightforward process. You find the right tools that can read the memory, hook that up to your computer, take the memory off, put it into whatever tool you need to read the contents off. So in theory, it would have been fine. It turns out by just looking at the chip, it looks like kind of a normal chip, but this ends up being something that we're seeing a lot of with more modern electronics and modern technology, is something called package on package. So instead of it being when you'd look at a circuit board, you'd see individual chips, and those chips would do individual things, maybe a microcontroller, maybe some external memory, maybe an analog to digital converter, control for a solenoid, for a industrial system, whatever it is. But now we see chips that are stacked on top of each other because it saves space on the circuit board, and it means that things can run much faster. Because if your signals are closer together, the bits get to the end at a faster time, and there's less chance of noise. So package on package is something that we see a lot, and that particular memory device that I was looking at happened to be package on package. I'd never worked with this type of memory device before, so it was a whole new thing. This is what it looks like in our situation, is we have all of the connections of the first chip on the bottom, and then there's these little kind of pockets in the plastic of the bottom chip that's called through mold vias, which are basically pockets where the next chip would sit on top, and then the solder would melt and connect the two together. So this is actually two chips on top of each other. When I first started doing my testing, because you always want to test your hack on something that you can control before you do it on the real thing, tested my hack, and like everything seemed to work fine. So I'm like, great, okay. It's going to be a piece of cake. I'm just going to remove the memory. But that didn't actually work out. Here's a view of what a package on package would look like. This is the two chips, one of the samples I had that I split apart. So this is the top chip. And usually there's going to be little balls of solder on here that make the electrical connections, but I had cleaned that off because when you heat solder, it melts and gets all over the place, so you have to clean it up. And this side, you can't really see it on the big screen, but each one of these connections has that little pocket where the ball fits into. So conceptually, it's like, oh, just put one on top of the other and heat it up again, and the two chips will melt and everything will be fine. So when I started doing this on another device, after my first one worked, the second one didn't work. Took the chip off the board, and I'm like, why am I not able to detect the memory? It turns out in this case, those two chips, one of them is the memory controller that connects to the microprocessor or whatever is talking to it and handles reading and writing to the actual memory itself. And then there was memory. So memory controller and memory. And you had to have both of those together in order for it to work. Unless you were hardcore and decided to go directly after the memory and you'd wire it up to some other stuff. But I didn't want to do that. I just wanted to get the memory and get it off the board. So the chip wasn't working. And I'm like, well, I can't see anything about it. Like, it's two chips, and my first experiment worked. Why is this one not working? I sent it to a guy that I've worked with before that specializes in like X-ray inspection, failure analysis. So he takes devices, puts them in the X-ray, and then looks for abnormalities or things that aren't working. And he identified like, okay, there's some connections of the chip are fine, but there's like these solder joints between chips. Or between the balls of the device. And I'm like, well, what do you mean? He said, when you heated the chip, since there's two chips, the top one must have slid a little bit, causing short circuits between the balls. And I'm like, oh no, like this is way outside of my skill level. I don't have X-ray. I don't have the equipment to reball the chip and put it all back together. But he said, I know a guy that can help fix that. So here we had two chips that were now basically smudged with solder, that had to be removed, cleaned up, put back together. But the beauty of technology and the beauty of building relationships with people that can do complementary things is repairing a device like this is not out of the realm of possibility because these chips have to be built in the same process. So there's already equipment that exists to do this type of work. I don't have access to it, but it turns out this other guy did. He was able to clean up all of the solder balls, clean up all the pockets, reball the chip, put them back together, and now here's an X-ray of the repaired version, which now there's no more solder balls on everything, and we could continue on with the project. So I thought that was really interesting, and this was recent. So this is like my hacker mentality is like, I'm going to just try it on my own, right? I'm going to try this complex technology and see what happens. And it turns out that my reference design, the first chip I was using, wasn't package on package. It was a chip that had both chips inside of one, so it didn't cause the problem of the slippage. But on the second one is when it slipped. So the lesson here is kind of twofold. One of them is, even if you think you're working on the similar type of device, you might not be. And that was a real eye-opener for me of like, the chips looked exactly the same, but they weren't actually manufactured with the same process. So that's a reminder for me of like, when I'm hacking on something, double check, triple check that the chip is the same. Because if I had known that there was this risk of slippage of the two chips, there's things I could have done. I could have glued the chips together. I could have cut the circuit board from the bottom side to not give any sort of physical stress of the device itself and not have to heat the device, but still get access to the pins from the other side. Like, there would have been solutions, but because my first experiment worked, I was like, I'm awesome. I'm going to do it. And then I failed. So it's good to know that you can kind of dig yourself out of those situations. And this was another one where it was like 3 a.m. when this happened. My heart sunk and I'm like, am I worthy? Like, should I be doing this stuff? Imposter syndrome comes around. And then the next morning I woke up and I was like, well, these things have to be manufactured. So somebody has to have a way to fix it. And then it was following that path instead. So it was this lesson of like, again, you can't always blame yourself. Even though I messed it up, I could blame myself for that. But I think I ended up being more happy about the fact of like, oh, there's people that can help you and fix this. So anyway, that was a really interesting and embarrassing moment. So you might have noticed the shirt I'm wearing. This is Bob Ross, a famous, very low-key painter from like, I think the 70s and 80s, maybe up to the 90s. Great hair. Love it. So he was always about like he would film these shows of painting, right? And he would like, if he made a mistake while he's painting, he's like, oh, we can just fix that up by adding a happy little tree or making a mistake into something positive. And when I started putting this presentation together, he popped into my head. I'm like, this is the guy that should be the final slide. Because his attitude, if he messed up a painting with real ink, right? Like that's a permanent thing, but he could change it. And his quote that he said a lot was like, as long as you're learning, you're not failing. And if you think about that combined with the slide at the beginning of you're learning if you're able to kind of look at your failures, right? Step back and look. And I have the shirt that says, no mistakes, just happy accidents, which is a lot easier said than done because at the time when you fail, it's definitely not a happy accident. But if you can step back later and say, that wasn't that bad. Like this is just part of the human process, right? Like it's okay to fail. What's more important is learning from that and coming up with a solution. And these have been sort of technical things, but it goes for everything in life. Being a husband and a daddy and a partner and a neighbor and all of these things. Like if you do something wrong, you can learn from that. And that's what this whole thing is about. And hopefully the presentation inspires you to be a little more comfortable with failing, a little more comfortable with sharing those fails with other people so we can all learn about different ways to solve problems. And with that, thank you for coming to the conference, to the keynote, and enjoy your time.
Thank you very much, Joe. Do we have any questions? Let me come over, so give you the mic.
As you show in your presentation, and you try to hack the chip package chip. So how do you try to probe the interconnection of the bottom chip and the upper chip?
How do we fix it?
No. How to try to probe the
to probe it. Yeah. So there was no documentation about that chip because it was a custom chip for like a mass produced consumer product. The bottom one, because it had pockets, you could in theory get little probes in there, but we didn't even care about what the connections were. We just knew that all of them had to be there. So it was less of reverse engineering the interconnection and more of just getting it right. But if you wanted to just take the memory off of the controller, then you could, to probe which pins were which of the memory, you could either use X-ray or there's some other non-destructive techniques. Acoustic microscopy is one where you're using sound waves to look in. And then you can try to figure out, without having to decap the chip, which ball connections go to which part of the memory to try to figure out like where the address lines are and the data lines, which would be more of like a monolithic flash memory approach, which we didn't end up having to do because we still had the controller that was functioning. It just was shifted. But it would take a lot more reverse engineering to figure out those connections if needed. Or really, you could spend the time trying to find the documentation somewhere, which would then save you some trouble.
Yeah. Did you make any silicon interposer stuff to do this?
Yeah. So I don't make any sort of interposers myself. But yeah, there's a company that comes to mind that I've used before called L0pht, which is like a Polish company that specializes in like NAND flash reconstruction. So they make different adapters. So if you knew the pinout, you could solder little wires from the top memory device onto the adapter and then use their software to pull the stuff off. So there are ways to do it. I didn't want to spend a huge amount of time on that particular project, but that would be one way to do it for sure.
Okay. Thank you.
Any more questions? If not, it is for our coffee break now.
Cool. All right.
Our next
Thank you
talk will
again.
be here at 10:30. Another round of applause.